Okay, today we're going to be working with a new type of function type. I call these functions power functions, and really what they are is just a creation of two functions put together in various ways to create a new function. So we're going to be defining two individual functions and then using basic operations to put them together. And so you can see that we have the operations of functions, and we can put different functions together with addition, subtraction, multiplication, and division. Now, this is a good chart or table to look at and learn and see some basic examples on the right side of the chart. You can kind of see some of the basic operations taking place with the same exact functions. Now, when we give you a function like f of x, or we give you a function like g of x, and we tell you what that is, we call that a defined function. So we're going to define a couple of functions for you, and then we're going to ask you to put them together with certain function operations. Now, that's just fancy term for addition, subtraction, multiplication, and division. So we'll look at each of those separately and work some sample problems in this first video on power functions. Now, let's look at the reason we're talking about power functions here. In previous lessons, we've learned about various types of functions, most specifically about linear functions and quadratic functions, and to a lesser degree about polynomial functions of higher degrees. So something like a cube or a fourth with a degree of 4. So, and of course we'll talk about those in more detail a little bit later as well. But basically, a power function is anything that is raised to a power. So you can see here we have a function, and it's being raised to the power of b. And a b is a rational number, and so we call that a power function. Now, the two main power functions that you've dealt with are linear, where b is equal to 1, and quadratic, where b is equal to 2. And we've also introduced the idea of b equaling to 3, which would be a cubic function. Now, basically, we've got to learn how to put these functions together through the use of different operations. So we're going to start with some simple addition and subtraction power functions. Now, when you're dealing with addition and subtraction, really all you're doing is combining like terms. And my pen's not working very well, so you have to excuse me. So we're going to be combining like terms. So the first thing we need to do is define the functions. So we have an f of x function, and we have a g of x function. So we have created two defined functions, and so sometimes you'll see that on standardized tests when they say the defined function. So don't let that bother you. That's just them telling you specifically what f of x equals to, or specifically what g of x equals to. And so then in the first problem, they want us to specifically find the new function when we add together f of x and g of x. Now, in some cases, you may even see that this is equal to a new function, and we could call that new function h of x, and we could define h of x as being a combination of f of x and g of x. Sometimes you'll see the third or new defined function there. Sometimes you won't. But simply, when you have a new function, or when you're doing function operations, and you have an f of x defined and you have a g of x defined, and we want to add those together, basically all we're doing is substituting. Okay, and when we substitute here, we're just going to simply put in the expression that represents f of x, and of course the expression that represents g of x, and we're going to combine those like terms. So we have 2 x to the 1/2 minus 6 x to the 1/2, and what we have there is we have like terms that we discussed in our exponent properties unit. And so all we simply need to do is take the coefficients, 2 and -6, and combine them to give us the -4. And you can see that the like term carries down to the final answer. So -4x to the 1/2 power is simplified. Now, there's no need at this point to rewrite that as a radical and go any farther. So we're just really focusing on combining the two given functions through addition or subtraction. Now, we can take the same exact functions and we can also do subtraction. And in this case, it would create a negative of a negative, so we would have to convert that to positive, and now we're simply adding these two like terms. And again, they both have x to the 1/2 power, so we can add them together to come up with a final simplification of 8x to the 1/2 power. So power functions are simply any time that we define a function that has a as being raised to a power or to an exponent, and that exponent can be any rational number. Typically we see it in terms that we're comfortable with, where we can combine the terms using the previous properties that we've learned. So let's take a look, and we have a couple sample problems down on the next page. So let's pause this video and work samples A and B. We've defined f of x and we've defined g of x for you. And so you can then combine them together to create the new function. So go ahead and pause the video and work sample A and B for me at this time. Okay. So what we have here is we have a function f of x. And f of x has been defined as 3x to the 1/3. So it's asking me in part A to find the sum of f of x and g of x. So what I need to do is I need to substitute. In place of f of x, I'm going to put its defined term, which is 3x to the 1/3. And of course, I'll simply add that to the defined term of g of x, which is 2x to the 1/3. Since these expressions have common terms, we can simply combine the coefficient, giving us 5x to the 1/3. And so that's our simplified or new function. And of course, if we wanted to, we could define that with a new function name like h of x or something of that nature. So that is simply adding the two functions. Now, part B asks us to find the difference of these two functions. So we would simply, again, substitute in for f of x and g of x. So we have 3x to the 1/3. This time we're doing subtraction, so we're going to have subtracting 2x to the 1/3. And simply again we have common terms. So in doing so we take 3 minus 2, which is going to equal to 1x to the 1/3. And of course we should know at this point that the 1 is just understood. So I'm going to erase that, and the final answer is just x to the 1/3 power. Again, no need to change this to radical form at this point. That is simplified far enough. Okay, so there's two examples of addition and subtraction, combining two defined functions together. Now we're going to move into multiplication and division. Now in multiplication and division, this is where we're going to now see the exponent properties that we've learned. So in the exponent properties, when we multiply and divide the defined functions, this is going to give us a situation a lot of times where we're multiplying variables with exponents. We're multiplying two numbers together, and so we need to know our various exponent properties for rational exponents and integer exponents. So that is extremely important that you remember that unit to be able to work these problems. And so if you look at the first two examples, we have f of x times g of x, and again this time f of x and g of x have been defined for us, and the combination of the two in this case is through multiplication. And so 3x times x to the 1/4 requires us to multiply the x values together, which means we have to add the exponents. Now, in that first term, f of x, it's understood that that exponent is a 1, so we'll need to add the 1 to the 1/4 in sample A. And you have a calculator that'll do that for you. So if you went to your calculator, you could simply add, and let me check my numbers, 1 plus 1/4, 1 plus, and I could simply do 1 divided by 4, and that's going to add those two together for us, equaling 5/4. So you can see our final answer is 3x to the 5/4 power. Now, on this part B, we're going to end up dividing the two functions, and so in this case, since there's an understood 1 in front of this, that's 3 divided by 1, which is 3. And then the x values, we have to subtract the exponents, and again, understood 1 with that x, so it's 1 minus 1/4. And again, you could use your calculator to come up with that exponent, so 3x to the 3/4 power. So let's take a look at a couple examples, or work a couple samples on your own. So sample problem number 2, part A and part B. We define f of x, and we define g of x for you, and then we want you to find the product and the quotient. So go ahead and pause the video and work on those two problems at this point. Okay. Again, we simply want to, in starting to work these problems, directly substitute in for f of x and g of x. And so for f of x, I'm going to have 4x to the 1/3 power. This time I'm going to use parentheses because I know I'm going to be multiplying these two together. And g of x is going to equal to x to the 1/2 power. And so we have f of x times g of x. Now we just need to multiply these two parts together. Well, there's an understood 1 here. So technically what we're going to be doing is we're going to be multiplying 4 times 1, and then we're going to be multiplying x to the 1/3 times x to the 1/2. So now we've kind of regrouped them so that we can put the two parts together. And so we're going to have 4, and in this case with the two x's, we'll need to add the exponents, which is 1/3 plus 1/2, which is going to give us the 5/6 power. So we can simply use our calculator for that as well. 1 divided by 3 gives us 1/3, plus 1 divided by 2, which gives us 1/2, and when we put that together we have 5/6. So you can see the answer is 4x to the 5/6 power, and that's simplified. Okay, so now let's take a look at part B. If you look at part B, we're dividing here, so we need to again substitute in. So we're going to be 4x to the 1/3 power divided by x to the 1/2 power, and again, let's not forget that that's an understood 1. So if I break this up into two parts, basically what we've got here is 4 divided by 1, which is 4, and of course with the x value we're going to subtract the exponents this time. And then if you use your calculator appropriately, what you're going to find is that we get 4x, and in this case we get a negative 1/6 power. Now, if you recall from our exponent properties unit, you cannot have a negative value in your negative exponent in your answer, so you have to change it around to create positive. So keep in mind this is understood to be over 1, and we're only dealing with the x value here. The negative 1/6 does not apply to the 4, so I'm going to want to switch this around and create our final answer of 4 over x to the 1/6, excuse me, power. And I apologize for the pen issues. So you can see here 4 over x to the 1/6 power is the simplified form from the division. Okay, and that finishes up our first set of examples. We'll come back in the next video and discuss composite operations. But you should get some practice at adding and subtracting defined functions, and then multiplying and dividing defined functions as well.